Welcome to this video lesson. Today we are going to introduce you to the concepts of vectors, and this is the part 1, and it's going to focus on one-dimensional vectors. In this video, we're going to be introducing you to the concept of vectors and scalars. One very useful tool that physicists often use from math is vectors. It is essential to understand this concept as we will be using it throughout the course. The essential idea here is that some quantities have direction and magnitude, while others have magnitude or size only. And this understanding is the key to correct manipulation of quantities. This subtopic will have broad application across multiple fields within physics and other sciences as well. Some of the learning goals for today include vector and scalar quantities, so understanding those, and also to learn how to combine, so application of combination and resolution of vectors. We will solve vector problems graphically and algebraically in other units, including forces and when we do motion and kinematics. Let's start off by talking about one-dimensional vectors. So in terms of dimension, if we have a dot, that's kind of like 0 dimensions. It doesn't have any dimensions. When we have a line, we're talking about 1 dimension. When we have a surface, we have 2 dimensions because the object can go in this direction and they can go in this direction. And when we have a rectangular prism, we are looking at 3 different dimensions. So this way, and this way. So this is going to be our 3 dimensions. And we are going to, at the moment, focus on 1 dimension and 2 dimensions, but the basics, let's start with the basics. A one-dimensional world is a very limited one. In this case, we're going to take positive direction in here, and the negative is going to be to the left. Our positive is going to be labeled east, and when you go west, you can go west, which is the opposite direction. We can also call that the negative east direction. We have a person here, and this person is walking in this direction, and let's say they start from here. Let's say this is their position 1, and let's say they reach here, which is position 2. In this journey, this person has moved, let's say, a distance of, I'm going to draw this with red. Let's say this distance over here was 2 kilometers. So now we can say that this person has moved from position 1 to 2, or their distance from location 1 to location 2 is 2 kilometers. Now, with distance, this quantity that we're talking about, we're not saying in which direction this person has moved. We are just saying that from this location to this location, the distance is 2 kilometers. This is called scalar quantity. So scalar quantity shows the magnitude or size of a measurement. And when we're talking about a vector quantity, it shows both magnitude or size and the direction of a measurement. Just going to use this. So in the first situation over here, this one over here, we call it distance. We'll talk about this much later when we're in the kinematics section. But to also talk about the direction that this person has moved, we're also going to, we have to express it as a vector. The vector always has a little arrow on top of it, and we're still looking at the vector from position 1 to 2, or the change in position from 1 to 2. And in this case, we have to represent that as 2 kilometers in the east direction. And this is our vector quantity. So this is kind of how we write it algebraically. So this person has moved to the east direction 2 kilometers. So let's write everything here. So D12 is equal to 2 kilometers east. Note that this value over here is the size of the vector. The bigger it is, that means that the person has moved more. Size or magnitude is the word that we use here. This is the unit. It means it could be meters, it could be kilometers, it all depends on the situation. And this is direction. So with a vector, we need 3 things. We need its size, unit, and direction. And if we were to represent the distance here, we don't really need to talk about we don't need to have the direction here. We'll just say it's 2 kilometers. The 2 is the size, and the kilometer is the unit. Let us look at a few examples here. So we are going to have this person, and let's take this to be a positive east direction, so it's positive there. And let's start here, go here, and then go here. So these are 3 different positions, and let's say this person starts here, and then they move here, and then they move here. And if we want, and let's give it a few distances here, this distance over here, let's call it 2 kilometers, and let's give distance as 1 kilometer. We are going to now focus on vectors, and we're going to leave the scalar for now. So initially, this person, D12, has moved 2 kilometers in the east direction, and then they have moved 1 kilometer in the east direction again in their next round. So to represent this using vectors, a vector itself is an arrow. So we draw an arrow, and this first arrow represents our displacement or the movements or the change in position from 1 to 2. And then to add to that, from position 2 to 3, they move in this direction. So this is kind of their movement, and this is how we show the movement geometrically. So this is kind of algebraically, and this is geometrically. Geometrically, a vector is an arrow. The starting point is the tail, and the end point is the arrow. So once again, this is the starting. So this is the tail of the vector, and this is the end, which is the head of the vector. For vector 2, this is the start, and this is the end, and this is the vector from position 2 to position 3. So geometrically, again, if I were to draw this outside of this location, this would be the first vector, D1 to 2, and this is 2 kilometers in the east direction. And the second vector, I'm going to add it right here. This is D2 to 3, and this is 1 kilometers in the east direction. To add two vectors geometrically, we basically we do exactly what we did here. We take the tail of the second vector, this one, and we place it directly on the head of the first vector. And the resultant vector starts from the beginning of the very first vector and goes all the way and ends at the end of the second vector. So this is how we add two vectors geometrically. So step 1 is to place tail of second vector on top of first, and step 2 is to draw a vector. This is the resultant vector from tail of first to head of last. And once again, this is geometric method of adding two vectors. Algebraically, when we want to add two vectors, if we have vector, and here I'm using a little triangle here. I should have been using a triangle everywhere. I'll tell you what that means later in when we are doing the motion unit. But in this case, the triangle means change. And this little section over here, so this D over here means position. And this is saying the change in position from 1 to 2, and this is saying the change in position from 2 to 3. So, and we'll discuss this much further later. But for now, if I were to add these two vectors, 2 to 3, you can see what ends up happening actually, because geometrically we start with position 1, we end at position 2, and then we are going to place the tail of the next one here, and we are going to look, our final position is going to be our third one. So when we add vectors like these, because the twos kind of are on top of each other, we'll end up getting 1 to 3. So geometrically, this is how it looks like, and if we, mathematically or algebraically, this is how it looks like, and we can also write it as 2 kilometers east plus 1 kilometer east is equal to 3 kilometer east. And this makes sense geometrically. We have 2 kilometers. The person travels from 1 to 2 for 2 kilometers, and then 2 to 3 for another kilometers, totaling 3 kilometers from position 1 to 3. Now let's look at some other situations. So here we have the same thing again. We're going to have east direction here. And let's say we have a person this time starting in position 1 and going to position 2. I'm not going to draw the person this time. And the person going in this direction, and let's say the distance here is 4 kilometers. And when we want to figure out this vector, we can use two different ideas. So we can say that since the direction to the right is east, then the person is traveling from location 1 to 2 for, or the change in their position is 4 kilometers in the west direction. So that's one method of writing it. Or we can write that their displacement is equal to negative 4 kilometers in the east direction. So in this case, our sign convention, we call this sign convention, and this person is traveling from this location to this location. Since east is our positive, then west is our negative. So we can either say this person travels 4 kilometers west, or we can say that since this is east, the person travels negative 4 kilometers in the east direction. This becomes very important a little bit later, but the other ways of thinking about this is that this is kind of like a negative vector. So 4 kilometer east is equivalent to negative 4 kilometers west, and 4 kilometers west is equivalent to negative 4 kilometers east. So this shouldn't be too hard of a concept. If our sign convention says that east is in this direction, if you travel in that direction, you're traveling in the positive east direction, and if you're going in the opposite direction, you're traveling negative. So now let's say we have two different vectors. We have one person going in this direction, so this is position 1 to 2. And let's say this is 7 kilometers. And then the person turns back and goes in this direction for 2 kilometers. And this is position 2 again. So this person went here and then stopped here and then moved in this direction. So we can use, and what we want to do is we want to add these two to figure out where is the final resultant location. So we will do this. We're going to use the same method as we did before when adding two vectors. So we're going to draw the first vector. I'm going to use blue for this. It's going to be going in this direction. And then we're going to take the tail. I'm going to use pink for this one. We're going to take the pink tail here, place it on the head, and we're going to add the second vector here. And the resultant vector, I'm going to draw that with purple, is going to start from here. It's going to start from the tail of the first vector, and it's going to end at the head of the last vector. And if we add these numbers, 7 minus 2 is pretty much 5 kilometers in the east direction. We're still taking this side to be positive east. Now, algebraically, I'm going to move this up a little bit. Algebraically, we can do this using two methods. The first one requires us to write all the values and all the units. So we can say that the displacement or the change in position from 1 to 3 is going to be equal to the displacement or change in position from 1 to 2 plus the change in position from 2 to 3. Okay, that's not too bad. But now let's give it some values. The first one is 7 kilometers in the east direction. And the next one, we can write it either as 2 kilometers to the west, but if we write 2 kilometers to the west, we can't add things. When we're adding the vectors, they need to be in the same direction. So we will have to change this from 2 kilometers west to negative 2 kilometers east. And now that we have this, we can simply go ahead and write this as 7 minus 2, which is 5 kilometers east. This is one method of writing it. It's nice in a way that it includes all of the units, the units and the direction in all of the lines, but it becomes a little bit challenging when you're doing this and you have too many vectors to add. You have to put so many different values and units and directions. So in order to simplify our lives a little bit, and as you get better and better, you can start using this method. In terms of the algebraic expressions, things don't change. We still have the total change in position from 1 to 3 is going to equal to the change in position from 1 to 2 plus the change in position from 2 to 3. What does change is you are going to define a direction to be positive. In this case, I'm going to choose positive east direction to just be positive and use this with my numbers. So I know that from 1 to 2, I'm traveling in this direction, which is in the same direction as my east. So I will use a positive value for that. And then for the next part, I am moving in the opposite direction. So it's 2 kilometers, but it's going in this direction, which is opposite to my sign convention. So instead of using positive, I will use negative because it's in the opposite direction. So the final result is going to be 5. The unit that I'm working with consistently is kilometers, and since I did all my calculations using this sign convention, my final answer is also in that direction. So my final answer should always include the unit and the direction. However, this method helps us avoid writing them throughout all our intermediate steps. Let's discuss subtracting vectors as well. So if we have two vectors, let's say we have a person which travels to the east. Let's take east to be positive again. And let's say we have a person which moves from 1 to 2, and then let's say 2 to 3 here, and let's say this is 10 kilometers, and this is, let's say, 5 kilometers. And we want to subtract the two vectors. So what do we do? Let's look at it algebraically first. So we have the change in position from 1 to 2 minus the change in position from 2 to 3. This is same as saying the change in position 1 to 2 plus minus the displacement 2 to 3, or change in position from 2 to 3. So this would simply means we can add, instead of subtracting, we can add the negative vector. And a negative vector simply means that we're changing its direction. So first one blue, next one is pink. And what we're going to do is we're going to draw out the first one geometrically. And then to subtract, we are going to take the second vector and change its direction. So we will have its negative. And we're going to add that vector into it by putting the tail on the head and drawing it out. And then a resultant vector is going to start from the very beginning, of vector 1 and end at the head of the second vector, or the last vector. So this is the process of subtracting vectors. So when we subtract vector, we just add the negative, and a negative vector simply means that we're changing the directions. I'll just add a heading here. This is subtracting. Let's talk about a few other concepts as well here. So I'm going to draw a line over here. See, the sign convention is something that we can choose ourselves. So I am going to actually choose my sign convention, and I'm going to take right. You can do it positive X, you can take the right to be positive W, you can even make right the west direction. You can make right the north direction. It doesn't really matter. In this case, I'm going to try to use the right direction as my north direction, or the positive north. So if I have two vectors, one is going this way and the other one is exactly half of its length in the opposite direction. So if my first vector here, for example, represents, let's choose a value, easy value, 20 kilometers, then if this, so the size of this vector is this 20, and the unit for it is kilometers. The direction of it is in the positive north direction. So if the size of this is 20, if this one is half of the size, then its size would be 10 kilometers. So this one is half. So I can call this D, and this one is going to, if this is D, this is going to be half of D, but the direction is also in the opposite direction, so I'm going to give it a negative sign here as well. So geometrically, if I were to write this, algebraically, this would be 20 kilometers north, and this would be, I'm just going to write this vector over here. This vector itself is going to be 10 kilometers south. Not the negative of it, but just the vector itself is 10 kilometers south because it's half. And that said, those are the concepts you really need to know for one-dimensional vectors. And let's use another video to cover the concepts for two-dimensional vectors.